Hi there, last class we have seen the physical properties of metals and non-metals. Today we'll see about the chemical properties of metals and non-metals. Okay, first of all, which element is called metal? The metal and the element which lose electron. Okay, lose electron and form a positive ion. Okay, when it lose one electron means then it become positive in nature, right? Metals. Elements which lose electrons and form a positive ions, it is called metal. Okay, whereas the elements which gain electrons and form negative ion, it is called non-metals. Okay, metals lose electrons and form positive ions. For example, Na gives Na plus 1 electron. Okay, so metals are called electropositive elements. Okay, so we can call this as a electropositive element. And Cl plus, it gains electron. Cl plus 1 electron will give Cl minus. Okay, so non-metals are electronegative elements. Non-metals are electronegative elements. Okay, metals, then reaction of metals with the oxygen. Okay, metal combines with oxygen to form basic oxide. Okay, so all the metals will combine with oxygen to form a basic oxide. For example, Mg plus O2 gives MgO. Okay, likewise non-metals combine with the oxygen to form acidic oxides. Okay, this metals combined with oxygen to form basic oxide, that means it's basic in nature. And here non-metals combines with oxygen to form acidic oxides or neutral oxides. It may be acidic or it may be neutral. Carbon plus oxygen gives carbon dioxide. Okay, next reaction of so the metal oxide has been formed, right? It is basic in nature. This basic oxides reacts with water to form bases. All the you know that we have studied in the last chapter, metal oxides will not react with water, but some of the metals like reactive metals like sodium and potassium will react with water. That we call as alkali. Do you remember that? So these some of these metallic oxide reacts with water to form bases. Okay, so some of these are potassium oxide and sodium oxide reacts with water to form potassium hydroxide and sodium hydroxide. Okay, here we mentioned that metal oxides are basic oxide. Okay, some of the metal oxides may be acidic in nature also, right? It has the property of both basic as well as acidic. That metal oxides are called amphoteric oxide. Okay, so it has both acidic and basic nature. Okay, example aluminium oxide, then zinc oxide, like that. Okay, so it has both acidic and basic property. Okay, next acidic oxides here. Coming to the non-metal, acidic oxide plus water gives acid. CO2 is acidic oxide plus water gives carbonic acid. H2CO3. Okay, gives the acid. Next, oxidation, reaction of these metals with the oxygen. Okay, few exception cases and some of the important things have been discussed. All these are observed from the experiment. Okay, from the activities it is observed that. Okay, oxidation process. Potassium and sodium, you know that it is very reactive metal, right? Potassium and sodium catches fire in oxygen. Okay, to prevent that fire, it is kept in the oil. Here it is kept immersed in, usually immersed in a kerosene. Okay, to prevent oxidation they are kept immersed in kerosene. So it always kept in a kerosene. Okay, it easily reacts with the water and oxygen, so it will not, so it is always kept under the in kerosene. Okay, then the some of the metals like magnesium, aluminum, zinc, lead, etc. are covered with a thin layer of their oxides, so no further oxidation takes place. Okay, we learned in the first layer, right, why the magnesium ribbon has to be rubbed before burning, right? because already some oxides are formed in that. Already it reacts with oxygen present in the atmosphere to form magnesium oxide, right? So it will prevent the further oxidation of that metal. So it has to be rubbed, right? Magnesium on heating burns. Magnesium on heating burns, forming magnesium oxide. That is, you know that the magnesium oxide is white in color, okay, the ash formed is. But when copper on heating, it coats with the black colored. It is what is the color of the copper oxide formed? It is black in color. It is black in color. Magnesium oxide is white in color. Then silver and gold do not react with oxygen, okay. So what we learned, potassium and sodium is a reactive metal, so it easily catches fire, so it always kept immersed in the kerosene, whereas magnesium, aluminum, zinc, lead are already coated with the oxide layer, okay, so it prevents a further oxidation. And this magnesium oxide forms is white in color, and on heating, when copper is heated, it forms a copper oxide which is black in color. Silver and gold do not react with oxygen at all, okay. Then what about this non-metals? Carbon dioxide and sulfur dioxide are acidic oxides, okay. These are acidic in nature, and some of the we know that this non-metal combines with oxygen to form acidic oxide as well as neutral oxide, right? So these two are acidic oxide, and carbon monoxide, water and nitrous oxide are neutral oxides, okay. These are neutral oxides, some of the neutral oxides. And then a jet of hydrogen gas burns in air. A jet of hydrogen gas burns in air with a pale blue flame, okay. When the hydrogen gas is burned in air, it burns with a pale blue flame, okay. The steam produced can be whatever the while burning the steam will be produced, right? The steam produced can be condensed to water, okay. If you condense that, it converted into water. It means H2 plus O2 gives H2O, okay. Next, then reaction with water. The sodium and potassium reacts violently with cold water, okay. When you put even a small amount in the cold water, it violently reacts with water, okay, and immediately hydrogen gas will be formed. If you put large amount of sodium or potassium in a cold water, it even catches fire. The hydrogen gases formed will catches fire, okay. Potassium plus water gives potassium hydroxide plus hydrogen gas, and sodium plus water gives sodium hydroxide plus hydrogen gas. Hydrogen gas will be evolved, okay. Next, this likewise this how this potassium and sodium reacts violently with cold water. Calcium reacts with cold water, but it is with less violent, okay, less violent, okay. Calcium plus water gives calcium hydroxide plus hydrogen gas, okay. It usually it will be flow. If you put a piece of this calcium or sodium or potassium, it will float on the water. It will move here and there like that, okay. It will be floating on the water while reacting, because of the bubbles hydrogen gas form, no, it stick to the surface, okay. So it reacts with less violent with cold water, but this magnesium, it will not react with the cold water, it reacts only with the hot water. Magnesium reacts only with the hot water. Magnesium plus water gives magnesium hydroxide plus hydrogen gas, okay. And this aluminum, zinc and iron, it will not react with either hot water or cold water. It reacts only with the steam, okay. It reacts only with the steam. What is it? Aluminum, zinc and reacts only with the steam, okay. Aluminum plus water give the steam. This is here, it is steam, okay. Aluminum oxide plus hydrogen gas. Iron plus water gives ferric oxide plus hydrogen gas. Zinc plus water gives zinc oxide plus hydrogen gas. Okay. Then this lead, copper, silver, gold do not react with water at all. Okay. What are the things? Lead, copper, silver, gold do not react with water. Okay. Sodium, potassium vigorously react with cold water, and calcium reacts with the cold water but with less violent. This magnesium reacts only with the hot water, and then what about this aluminum, zinc and iron reacts only with the steam. Okay. And this lead, copper and silver and gold do not react with water at all. Okay. Next, non-metals. Non-metals do not react with water to evolve hydrogen gas. Okay, it will not react with water. Okay, fine. Next, reaction with chlorine. Metal reacts with chlorine to form ionic metal chloride. Okay. Calcium, it is an electron donor. You know that it will lose electron, and this chlorine is a non-metal which accept electron. We know that. Okay. So Ca gives Ca2 plus 2 electrons. It will lose electrons, and this chlorine will gain 2 electrons from this. Okay. So the final reaction will be Ca2 plus 2 Cl minus gives CaCl2. Okay. Metal chloride, calcium chloride. Okay. And this non-metal reacts with chlorine to form covalent chloride. Okay. To form covalent chloride. P4 plus 6 Cl2 gives 4 PCl3. Okay. Phosphorus chloride. Okay. Then reaction with acids. Reaction of metals with acid. Metal reacts with these we have studied in the last chapter itself. Metal reacts with dilute hydrochloric acid and sulfuric acid to liberate hydrogen gas. That is, metal plus acid gives salt plus hydrogen gas. Okay. But when reacts with dilute nitric acid, hydrogen gas is not evolved. Okay. Instead of water is formed. Usually the metal reacts with acid to form salt and water, when the acids are hydrochloric acid and sulfuric acid. But in case of a nitric acid, it does not evolve the hydrogen gas. Okay. Instead of that, it produces water. Hydrogen gas is not evolved, but water is formed. Why? Because nitric acid is a strong oxidizing agent. Okay. It is an oxidizing agent. It oxidizes the hydrogen produced to water. Okay. It oxidizes the hydrogen produced to water and itself reduce, and the nitric acid itself get reduced to nitrogen oxides. Metal plus dilute nitric acid gives metal salt plus water plus oxides of nitrogen. So it oxidizes the hydrogen to water, and itself it oxidizes to form oxides of nitrogen. Okay. And exception in this case is magnesium and manganese evolve hydrogen gas with dilute nitric acid. Okay. When the metals react with dilute nitric acid, it forms metal salt plus water plus oxides of nitrogen, and the exception cases are magnesium and manganese. Magnesium and manganese evolve hydrogen gas with the dilute nitric acid. Okay. In case of non-metals, they do not displace hydrogen from acid, because non-metals are electron acceptor and they cannot supply electron through hydrogen. Okay. Next, coming to the reaction with hydrogen. Hydrogen can share or lose electron. It can do anything. Okay. But active metals like sodium, potassium and calcium can force hydrogen atom to accept the electron to form hydrates. Okay. So sodium plus hydrogen gives sodium hydride. Calcium plus hydrogen gives calcium hydride. Okay. Here Hydrates of non-metals are stable compounds and formed by sharing electrons. Here non-metals reacts with hydrogen to form hydrates, but it is a stable compound. Okay, this nitrogen plus hydrogen gives ammonia gas. Okay, it is a stable compound. And hydrogen plus sulfide gives hydrogen sulfide. Okay, so that's all about this important things about the chemical properties of metals and non-metals, and all these things are based on the activity done in the book. Okay, thank you.